Okay, so the next video in this series is now we're going to look at equations of linear functions, and we're going to look at three different types. And so this is the first of the three videos about the different ways, the different types of equations, the different ways we can write them. And so the first one is called slope y-intercept form. So we've already spent a lot of time talking about slope, and hopefully you remember the y-intercept from the previous chapter. The y-intercept is where does the line intersect with the y-axis. So that's kind of what we're talking about there. And in the previous chapter, we called this the initial value or the initial sum or something like that. So let's look at an example that's very similar to what we did in the previous chapter. And this says a cell phone plan has a monthly basic fee and then a charge for every minute of use beyond the first 100 minutes, which are free. So you get to use 100 minutes and then after that there is a fee. So here we have a graph showing that. So you can see it starts here at $30 and then the time beyond 100 minutes. After we use the phone for 20 minutes, we have to pay 35, 40 minutes, 40, 60 minutes, 45, and so on. So this is a linear relationship, but how do we know that it's a linear function? Well, the graph is a line. It's as simple as that. So there's no trick there. It's a line. It's not a curve. What is the slope? And what does it represent in this situation? All right, so if we want to calculate the slope, I can use the points on the graph as coordinates. I can also draw in that triangle. That was the other technique, right, that we learned, where this is the change in y and this is the change in x, the vertical change and the horizontal change. So over here, I'm going over 1, 2, 3 kind of steps, but that's actually 60. So this is 60 minutes. And up here, for change in y, I'm going up 3 as well. 1, 2, 3, but each of those are worth 5. So this is really $15. So that's 15. Remember, the slope is the change in y over the change in x. So that's 15 is what I was saying. $15 over 60 minutes. That's $0.25 per minute. So what does that represent? Well, the slope in this case of 0.25 represents the cost per minute of using the phone after those 100 included minutes. This is maybe not the best deal out there, but just to illustrate the point. And often in linear functions, we would write the slope in fraction form as well. So there's our fraction form of a quarter. What is the y-intercept? Well, the y-intercept was back here, and I've kind of written over it, but there you go. And this is kind of a blurry graph. Sorry about that, guys, but this is at 30. So the y-intercept is at the coordinate 0, 30. And what is it? Well, it's $30. And what does it represent? It is the base fee that I have to pay every month. So it said I have a monthly basic fee. That's where my payment starts. And if I don't use any time beyond the 100 minutes, I still have to pay that $30. So that's what that represents. And now write the equation that models this scenario. So in the previous unit, we saw an example where I would say that the dependent variable equals the rate of change, which I'm just going to abbreviate that way, times the independent variable plus the initial value. So the dependent variable is the y, the concept on the y-axis, which is cost. So I could use the letter C. The rate of change is 0.25 times the dependent variable, which is time, or sorry, the independent variable, which is time. Maybe I'll use the variable t plus the initial value of 30. Okay, so that would be my equation. The rate of change really is the slope, isn't it? So those two ideas are identical. It's just in the other chapter we called it rate of change. The independent variable, that's my x, and the initial value is the y-intercept. So that's why we call this the slope y-intercept form. And here it is, y equals mx plus b. And those of you that have taken a science course, maybe you've studied that already and know that. So this is my equation, y equals m times x, where m, well, we know m is the slope. And we know how to calculate the slope already. So we've got that as a tool. And b represents this point right here, the y-intercept. So b is the y-intercept. And that's our equation. So let's look at some questions where we're practicing this form of the equation, mx plus b. So first of all, we're given some information and we're just going to plop it into the equation where it goes. So m, that's the slope, and b, that's the y-intercept. So this says state the equation in that form given this data. The slope is -2. Okay, so I'm going to go y equals -2. This is m, plus b, well, b is -5, so -5. And there's my equation. The y and the x don't change. Those are our variables in the equation. Next one, maybe you can try this one. So hopefully you got -2/3 x plus 7. Okay, not particularly difficult there. But then what are the skills that you need to have with mx plus b? Well, there's really two things. I give you the equation and you graph it like this. Here's the equation, you graph it. Or alternatively down here, I give you the graph and you give me the equation in the form mx plus b. So let's see how that works. All right, when graphing, I look at the equation that I'm given, y equals 2/3 x plus 6. Well, this tells me two things. I know that b is 6, so I know that the graph is going to cross right here. That's the y-intercept. And I know that m, the slope, is 2/3. So now I'm just going to use the slope to plot a second point. So I'm going to write here b equals 6, so plot the y-intercept. Okay, that's not very difficult. And then m, use the slope to plot some more points. You don't need to plot a whole bunch. You could really just plot one and connect them with a ruler, and there you go. So I rise 2, 1, 2, and I run 3, 1, 2, 3. There you go. Rise 2, up 2, over 3. Alternatively, remember that 2/3 is the same as -2 over -3. So I could actually go down 2 and backwards 3. And that would be on the same line. You can see that these are all going to be on the same line. So there's my first linear function, 2/3 x plus 6. So why don't you pause the video here, and now you try this one, and we'll see if we get the same answer. Okay, so hopefully you saw that b is -2, and I'm going to plot that. Boom, -2. There it is. Then the slope is -1/5. So I'm going to rise -1. That means I'm going to go down 1, and I'm going to go over 5. 1, 2, 3, 4, 5. You can see there. All right. I could repeat that. Down 1 over 5. There it is. The other way I could understand -1/5 is 1 over -5. So this way I'm going to rise 1 and go backwards 5. Rise 1, go backwards 5. And now I've got these 5 points. I'm going to connect them on here like that. All right, it's a bit tricky on the iPad I'm using to show that nicely, but there's my line. All right, so hopefully you got that. And now down here, I have to get m and I have to get b from this graph and plop them into the equation where they belong. So hopefully you can all see that right here, is where the graph crosses the y-axis. So that's at 4. That's b. So I already know it's y equals mx plus 4. Well, that's good. I've got half the information that I need. And now to determine the slope, well, I've put dots on two particular points here and here that we could use to help us find the slope. So I can either use the slope formula, y2 minus y1 over x2 minus x1, and calculate the slope using these coordinates, -6, 8, and down here this looks like 6, 0. So that would be one way. That's maybe a little bit more work than I want to do. So I'm going to erase that, and I'm going to try a different technique, which is to just draw in that triangle. And I want to make sure I go to a point where it crosses exactly, right? I don't want to pick something like this where I don't know where that is exactly. So I want to make sure I pick a good point to use. All right. So here I've gone down, which is the negative direction. 1, 2, 3, 4. So that's my change in y, -4. And then I'm going to the right, which is the positive direction. 1, 2, 3, 4, 5, 6. So the slope of this line is -4 over 6. And now we're grade 10 students, so we're not going to just leave this -4 over 6. I'm going to reduce this to -2 over 3. So now I have m, I had b from before. I'm going to put it all together. My answer is -2/3 x plus 4. And that's the answer for the first one. So again, here, maybe what I'd suggest is pausing the video. You try this one, and then see if we get the same answer. Okay, so in this last question, again, I want to find where is b? B is right here. That's the y-intercept, where the line crosses the y-axis. So b is at -2. And then I want to calculate the slope. So I can go 1, 2, 3, 4 up, and 1 over 4, 1. This is the change in y, because it's my vertical change. And the change in x is 1. And they're both in the positive direction, up and to the right. So m is the change in y over the change in x, which is 4 over 1. So it's 4. And now I put those into my equation. Y is 4x minus